Ukraine!
Yeah, Ukraine!
quadSquad, and a very, very distinguished panel of judges who've joined us from around the world for the finalist presentations today. We have Guillaume Belmas from VNext, Beata Bodziński, who's the president of the Institute of Industrial Design, Warsaw, Guy Wallart, CTO of Coca-Cola, David Rowe from Uniseed, Richard Ferres, who is the Developer Relations and VP from Nokia, and Annette Cutliff from Pacific Services, United Credit Union, CIO, and then finally Rob Miles, a software design captain, a professor at the University of Hull. And of course, very importantly, I'd like to introduce the team from Ukraine. I might hand over to you to introduce yourselves and then get on with your presentation. Good luck.
Thank you.
Thank you.
I'm sorry.
Good day, ladies and gentlemen, honorable judges and guests. Our team is called quadSquad, and we're here to present to you a project, Enable Talk. Now, conscious communication is the basic ability that sets us apart from all other living creatures. You could say this is exactly what makes us human. We constantly communicate with each other. We share with each other our feelings, our thoughts, our experiences. We learn from other people things we do not know yet. We talk to other people on our job for mutual benefit and welfare. Yet there is a group of people among us, people with hearing and speech impairments, basically those who can either not speak or not hear or both. And these people, they find it difficult to engage in seemingly everyday activities. Just think about something that you do every day, like talking to a shop assistant in the store, or asking directions from the passers-by, or studying at school or university, talking to colleagues and clients on the job, simply socializing, having fun with other people. Everything becomes difficult and challenging once you cannot simply voice your thoughts and opinions and get a response to them. According to the Gallaudet Research Institute in Washington, D.C., more than 40 million people in the world suffer from these problems. More than 40 million people cannot communicate effectively with the outside world. And this huge number is growing every single day. The world is simply silent to them, and they feel isolated. We as a team, we were very surprised to find out that even with the current development of technology, not a single commercially available device exists that can translate sign language into speech. Not a single device to help these people lead a good life, lead a full life, achieve their full potential, and become productive members of society. And we as a team, we think that this has to change because the technology of today gives us so many tools to work with and solve the problems of other people. And we're committed to changing that situation. That's why now we're proud to present to you our solution to the language barrier between the sign language users and the rest of the world.
Nice to meet you.
Here you can see our specially designed sensory gloves that can capture hand movements, and with the help of our software solution that's running on the mobile device, they transform sign language into speech. And here's how a system generally works. First, you have to capture the sign, either a hand movement or a gesture as the user makes it. Then, using our application on the mobile device, we receive the data and recognize that sign and match it to the existing signs and patterns stored in memory. And after the recognition process is over, we play the sound for that sign through the mobile device sound system. Now, the first thing that you have to do, as I said, is to capture the hand movement. So to do this, we have equipped our gloves with flex sensors. You can see them over there. 11 flex sensors for each glove, and they capture the hand movements and hand flexing. And also a compass, a gyroscope, and an accelerometer. These are the sensors that we have built in our controller. You can see here's another sample of our controller. These are the sensors, and they capture the data as the hand moves through space. And would you like to say something? Would you like to describe our...
No problem.
Yes.
No problem.
Okay, here's some of our components. We have ordered them all over the world. And I would like to show you our prototype building process. As you see, it's a handmade process. We have put all our efforts to make our prototype small and portable. And here's our prototype. We would like to show you a video of our prototype building process. It goes like this. You can see that that everything starts from a kitchen and our prototype is true. We have traveled a long road in the process of developing and debugging this device. We have tried different approaches. We have a variety of prototype, debug boards, PCBs, and so on. We have spoiled several gardening gloves and microchip in the process. Now you can see how I'm soldering these components. It's late night and many hours, many hours. And now I'm soldering other components, for example, Bluetooth module, you can see, and others. These components use in prototype. We generally get them from other countries, from China, from USA, from Ukraine. And now you can see I'm soldering a gyroscope. It's a real small one. It's only 7 millimeters long. And here's now our controller. It's the main part of our device. It uses small and powerful X-Mega microcontroller produced by Atmel. Also, we use accelerometer, gyroscope, and compass sensors to get position of our device in space.
And also, as I mentioned before, we use these flex sensors. They are installed on the glove. As you can see here, they're sewn on the fingers. And what's special about the flex sensors is that they bend really well, and they transfer the degree of the bend into electrical resistance. So the more the sensor bends, the less the resistance. And we use analog digital converters on our controller in order to capture the data. And that is how we can always tell what the position of the user's hand is. And again, to the microcontroller. This microcontroller, it gathers the data from all of the sensors. It normalizes it and analyzes it and compresses the data into the packets of 59 bytes that are then transmitted through this Bluetooth module to the mobile device for further analysis. And also we have equipped our controller with the battery, a lithium polymer battery that powers our device. And we have installed a solar panel on top of our controller to provide for additional source of power when, for example, sun is outside, to extend its working time and also to make it more environment friendly. Please pass it along with sensors. Anton, sensors, please. And as you can see, our system is, it took us a long time to develop our system, and it's really rather complex, but it really actually works.
System really works.
And now I would like to talk a little bit more about our software solution. As I said before, the first part of our solution is running on the microcontroller. It's embedded there, and we have written it in the C programming language. It gathers data from all of the glove sensors and analyzes it and passes it further along. The second part is the part that's running on a mobile device and is in charge of recognizing signs and matching them with the existing stored signs and patterns. And we implemented this solution for Windows Phone, for Windows Mobile, and we have written it in C#. It uses mainly statistical analysis and templates for recognition and Microsoft Speech API for vocalizing the signs. The recognition process is based on a mathematical model. This model accepts 23 inputs from the signals that are coming from the glove, And we use adaptive algorithms and apply rigorous statistical analysis to that data. We use filters such as Kalman's filter and dynamically generated importance sampling to bring down the noise and to make a recognition process more simple and stable. Our system is completely user-taught. We estimate that it takes at most 5 to 10 repetitions from the user to teach our system a new sign. And that makes our system really flexible and responsive to the needs of individual users. You don't have to make a sign the way some standard tells you to. It's really individual. The way you make it, the way it's comfortable for you, that's how our system is going to read it. And after the recognition process is over, we generate the exact text equivalent for that sign. And then use Microsoft Speech API to vocalize that sign through the mobile device sound system. And now we would like to show you some demonstration. Are you ready?
Yes. Of course. Australia is a great country. We are happy to be here.
We would like to show you some graphs.
Some more, I
Some
think.
more?
Yes.
Okay, sure.
We want to see kangaroo.
And now graphs.
Okay. Переключаешь?
Переключай.
Here you can see the graphs of the data flow that's coming from the sensors in a glove. The upper part is from one glove and the lower from another. And as you can see, there are two accelerometers in the first and third quadrant. And then there is a compass and a gyroscope. And obviously, as the hand moves through space, the readings of the sensors change. For example, when Anton moves his hand like this, you can see that the accelerometer sensors are responding really wildly. And for example, a gyroscope gives us the angular rotation vector, so when the hand rotates, it also shows us. And we have a filtered and unfiltered version of the data, like this. So
We use Kalman's filter.
these graphs are more smooth, and they're filtered for noise, which makes the recognition process a lot more simple and stable. And now we'd like to show you the data flow from the flex sensors that are installed on the fingers. As you can see, as the hand is being flexed, also these readings change. And for example, can you flex just one finger? As you can see, all of them are flat, and just those that are responsible, the two sensors for each finger, we get those readings.
Это.
And obviously, we would like to make our system as mobile and portable as possible. That's why we have implemented a solution for a mobile device.
Connect.
Now, unfortunately, Windows Phone 7 doesn't have access for Bluetooth for developers. That is why we had to implement our solution on the Windows Mobile. But we're really hoping that when Windows Phone 8 comes out, it will have this feature, and we'll be able to implement our system there immediately. So please.
Hello from smartphone. Can you help me? Be my friend.
Yeah, so this is how our system works.
Готов? Разверни на полный. Полный разверни. Полный.
And now we would like to show you also a 3D model of our glove. This is the model that we have built to test how it responds to the movements. And as you can see, it responds precisely the way the hand moves. And as the fingers are being flexed, it's also reflected on the model. And we think that we'll be able to use it in the future to help users teach our system new signs so that they can see what kind of sign they're actually making and if it's being recorded correctly. Let's go. And
Sorry.
And now we'd like to say a few words about our business model. Now, obviously, we have completed the first steps towards building a business. First of all, we have identified our customer base, we have researched their problems, we know what their needs are, and we have created a solution that we think can adequately address those needs and help them communicate better. We have created this solution and we have already submitted it for initial testing to our potential customers. The main feedback that we got from them was to implement hand gestures recognition as opposed to simple finger gestures and letter signing. They told us that it's more comfortable for them not to sign letters but to use broad gestures. And as you have seen, we have taken account of their feedback, and the result is the solution that you can see in front of you today, the working system that can help them. And in the market, there were some attempts to implement systems like this before. And as you can see, for example, there is Excel glove that was produced some time ago, but the price is rather high. As you can see, $1,200. And with that, they provide only the device. There is no software available. They basically offer, here's the glove, do what you will. And there are only just 5 flex sensors, and it's obviously not wireless. It has to be connected to the phone directly. And also there is a glove for the deaf with the estimated price of $800 to $2,000. That's obviously only an estimate because it never went into mass production as far as we know. And as you can see, there is no way to integrate it with a mobile device because it works through what appears to be a radio antenna and has only 10 flex sensors and only letters recognition, no gesture recognition, obviously. And we have developed an approximate business model that would allow us to finish developing and start manufacturing and selling our gloves. The startup costs would be around $400,000, and included in those costs are software development, system testing, pre-production, manufacturing, advertising and promotion, and initial sales costs. The current manufacturing cost of our prototype is $150, but obviously it's a single device and a handmade device. We estimated it will drop to $75 per device should it go into mass production due to the economies of scale. And this would give us $125 of profit from a single device. Thus, we would need to sell only 1,600 pairs of devices to cover our initial costs. And given the potential size of our market of 40 million users in the world, we estimate that it will happen within 3 or 4 quarters from the introduction of our device to the market, due to the size of the market and absence of any viable competition. And in order to summarize, I would like to list the main advantages that we think will make it more attractive, will make our system attractive both to the consumers and to the investors. Now, first of all, it is unique. No other system does what our system does. There are some systems that do parts of our task, but it's not implemented completely, the whole complex, such as the letter recognition, the gesture recognition, the wireless version, and a system that can be taught by the user himself. It's easy to use. If you already know sign language, you simply put the gloves on and act as you have always done. There is no need to change your habits. There is no need to change your behavior. Our device is responsive to the needs of individual users. It's really easy. It's ultra portable. Again, just a pair of gloves, no need for special storing conditions, no need for much space to store. So you can take them anywhere with you and they can help you. It's flexible. We chose to run our prototype in English and American Sign Language, but it doesn't have to be this way. Basically, you can implement it for any of the spoken languages supported by Microsoft Speech API and any of the sign languages. You can even make your own language if you like to. It doesn't really matter for our system. Long battery life. We have tested our device, and we estimate that it can last up to 8 hours of continuous use. And that's not counting the solar panel. Obviously, if it's a sunny day outside, and you use our system and it charges from the sun, the working time extends greatly. It's cheap to produce. The estimated cost is $75 per device, which isn't much for a system this complex that attempts to solve the problem of millions of users. Large target audience. 40 million people in the world suffer from this, and we think the numbers are actually underreported from various countries due to government statistics. And we know how to reach those people. Phone use possibility. This is still in development, but we think that it's a really exciting feature that will eventually will happen. We think that it's possible to implement a conversation over a mobile phone with a person who uses sign language on one side and just about anybody else on the other side. And we're working on this. So again, our device is unique. It's easy to use. It's ultra portable, flexible, has long battery life, is cheap to produce, targets a large audience, and has some very exciting potential possibilities. And we encourage you to go to our website, enabletalk.com. That spells out in the detail all the features of our system. And we hope, obviously, that you can help us make a difference in the lives of millions of other people. Thank you. And just a final word from our captain.
We love Imagine Cup.
Disconnect.
Thank you. Very good presentation. I'd like to know something more about the trials that you've done so far and whether hand size matters at all in using the gloves, say for a child versus an adult. Is there any problems there? Thank you.
Yes. Could you show us the video?
Just a second.
We would like to show you a short video of one of the people that we worked with. And you can see the way she signs.
There's the subtitles.
И поможет ли он ей в жизни в будущем?
Понимаешь, надо всем рассказать, польза какая от этого прибора. Знают, сделали прибор, хотят, чтобы все посмотрели, хороший или плохой. Люди не знают, не слышат, дома сидят, дома не знают ничего.
So as you can see, she uses both the gestures, such as this one, for example, and also spells out the individual letters. And she was with her mother, and that's basically one of the very few people she can communicate with. And we were actually very moved by her story. She's a very accomplished athlete. Been to Canada not so long ago and competed in some track and field competitions and got medal. But unfortunately, it's really hard for her to communicate. And she's one of the people we tested our system with, and she was really excited. And that's when she told us that we need to move to broader gestures, not just the letter signing. And we tested our system with about a dozen of people from the Society of Deaf People in our city. And that was a very productive experience, I would say. They gave us a lot of feedback, and they were really excited to actually have a ready version that they could use in the future if we are able to produce and sell them.
Thank you.
Great presentation, really great. My question for you is, have you thought about putting in a mechanism where the wearer of the gloves could maybe approve or not approve if they do a gesture that doesn't say what they want to say, and they can cancel it and go back?
Yes, of course. This program that you've seen, it's mostly for developing purposes, for us to test our system. We're yet to add the user interface, but we think that we obviously are asking some money, and part of that is software development, and we think we just wanted to focus on making an application and a device that actually work, and then worry about the the pretty design later. But of course, that's a necessary feature because the recognition rate of our system is about 90% right now. We're shooting for 99.9, of course, but still to reach that goal. But of course, the user has to have the option to decline the translation and to change it in some way, perhaps.
Thank you.
But just to clarify that, if our system has not recognized a sign, it will not feed you some gibberish. It will simply stay silent and ask for another sign to be made. So the chances of miscommunication are not so great.
Thank you.
Thanks for your presentation. I'm David Rowe from Uniseed. The gloves are really impressive, but you do highlight there's another couple of solutions that were out there previously. So how are you guys going to protect your solution, and that could relate to intellectual property or patents?
Yes, thank you. Well, the thing is, we're really not businessmen, so not sure how the we know that the patent search and the patent in general is really expensive and lengthy process. So we chose for now to focus on the actual development. If our project is going to move to the actual business stage, of course, that's the primary concern, because we wouldn't. That's something you have to do, obviously, but not for now.
That's right. Thank you.
Thank you.
My question is related to possible expansions of use of the technology, of the core technology. I know the main purposes and focus is rightfully so on improving people's lives, but could there be applications in the gaming technology of this, which might help your business model and therefore help people even faster?
Thank you. We've got some feedback from the judges in the previous few days, and some of the possible uses were offered to us, some very interesting that we had never even thought about. And, but obviously for now we chose to focus on this problem and not to spread out to trying to achieve too many things at once and not doing anything at all. But first we would like to solve the problem of these people actually. And then, yes, of course, there are all kinds of implications and all kinds of uses we could put our system to, but that's, I think, for further development.
Okay. Доброго ранку.
Добрий день.
Доброго ранку вам також.
Okay. Congratulations because of Euro 2012 in Kiev. Great job.
Thank you.
Okay, now about the launching this product on the market. Please tell me, how do you want to promote it and how do you want to launch that on the market? Okay.
Thank you. Well, we thought about worldwide distribution, but obviously first we would start from our own country. And for example, there are more than 400 societies of deaf people in Ukraine. And obviously they're used to organize people who suffer from this problem. And we think that the most effective way in the beginning would be go into those societies and, for example, giving them one prototype each for testing purposes, and so that people could see how it actually works for them. And then if they like it, they are obviously welcome to buy it.
Congratulations for your project. Very cool demonstration.
Thank you.
I have a question about the way you train the system. You told us that the user have to train the system in order to learn word and sentence. Can you tell me more about that? Do we have to train the system in order to make it pronounce each and every word you're willing to say before using the system? Or do you have a learning mechanism?
Well, the thing, it's not complete yet, but the way we wanted to do it is to develop a library of signs that a user can download from our website, for example, and of standard signs, the way they're usually made. And if the user can reproduce those signs, if that's how he does it, that's fine. He can use the standard library. But if there are differences, he obviously can customize some signs, change them in the way it fits him or her, or even at his own signs. So obviously, teaching all the 20, 30,000 signs would be tiresome work for anyone. So we have to provide initial package, but then also allow for customization of user experience.
Thank you.
Thank you.
A technical question. I watched the girl in your video moving her hands really quickly. Are you happy that the data rate you have to transfer the movement information from your device can keep up with hands going that quick?
Well, technically, there is basically no limit to how fast we can transmit the data, because in the gloves we use fast protocols such as A2C and I2C, and we use Bluetooth for data transmission from the gloves to the computer. There are certain lags with our algorithms, but we're working on that, obviously, and we expect it to improve.
So how many samples a second are you taking for each thing? If I'm doing that, how many samples a second are you taking of each sensor input?
Just a second, please. Сколько раз за секунду ты снимаешь данные с датчиков?
Получается, раз в 150 миллисекунд.
Once in 150 milliseconds.
Oh wow, okay, that's quick. Yes,
and obviously some of the problems is we are not sign language users, so we cannot make the signs as fast as she obviously can. So maybe if we could bring her here, she could show it much better and much faster, but we cannot do that.
Good work.
Congratulations.
Thank you.
You are a remarkable young man, and my heart was full just listening to you. Well done, and congratulations on getting to the finalists of Imagine Cup. And Imagine Cup loves you too. Well done.
Thank you.
Thank you. Started. Again, if you're new to the room, would you mind turning off your mobile phone, making sure we've got complete silence in the room? Also, I'd like to introduce the Ukraine team. Go Ukraine!
Yeah, Ukraine!
quadSquad, and a very, very distinguished panel of judges who've joined us from around the world for the finalist presentations today. We have Guillaume Belmas from VNext, Beata Bodzinski, who's the president of the Institute of Industrial Design, Warsaw, Guy Wallat, CTO of Coca-Cola, David Rowe from Uniseed, Richard Ferris, who is the Developer Relations and VP from Nokia, and Annette Cutliff from Pacific Services, United Credit Union, CIO, and then finally Rob Miles, a software design captain, a professor at the University of Hull. And of course, very importantly, I'd like to introduce the team from Ukraine. I might hand over to you to introduce yourselves and then get on with your presentation. Good luck.
Thank you.
Thank you.
I'm sorry.
Good day, ladies and gentlemen, honorable judges and guests. Our team is called quadSquad, and we're here to present to you our project, Enable Talk. Now, conscious communication is the basic ability that sets us apart from all other living creatures. You could say, this is exactly what makes us human. We constantly communicate with each other. We share with each other our feelings, our thoughts, our experiences. We learn from other people things we do not know yet. We talk to other people on our job for mutual benefit and welfare. Yet there is a group of people among us, people with hearing and speech impairments, basically those who can either not speak or not hear or both. And these people, they find it difficult to engage in seemingly everyday activities. Just think about something that you do every day, like talking to a shop assistant in the store,